Okay, welcome back. We are going to solve the problems for chapter 6. It's about gravitational forces and circular motion. This is the what you have to know. When you have two masses, capital M, little m, there is an interaction between them, a gravitational interaction due to the masses. And the mass capital M is acting on little m, and the force acting on little m due to the capital M, the force is on the line connecting the two of them. And the force is an attracting force, is going to the left. So if the unitary vector directional vector is r, the force is going in the negative direction of the vector r, is negative r. And the magnitude of the force is here. The force is proportional. This is a constant of proportionality. The product at the mass inversely proportional to the distance squared that separate the two masses. This is r that separate the two masses. This is the magnitude of r, or the distance that separate. You have to know that force is mass by acceleration. So the force acting on m, due to m, is mass acting on m, the mass by the acceleration. So this is equal minus m divided by the magnitude of r squared in the direction of r. So the acceleration is m magnitude of r squared in the direction of r negative. And this acceleration that is due to gravitational force is normally called g. The g acceleration is gm divided by magnitude of r squared in the directional vector r, in the opposite direction of the vector directional r with a cap, unitary vector. So let's go now the problems. First problem. The first problem, it says there is no gravitational force here. There is gravitational force, but there is a constant gravitational force that is mg. This is a gravitational force, but it's different from what I have said. What I have said is about big masses producing gravitational force. This mg is the force that the Earth, the big mass m, is doing on little m. But we are supposing that this force is constant, mg, m by the local g. We are supposing that this force is not changing when I move the mass m further. For example, that the distance between them increase. In the case that we are talking about the F equal mg, as you see, the structure of this equation say that m by a is m by g. So the a is the g. But we are considering using this equation that the acceleration is constant. Okay, let's go to do this constant and the value is g. Okay, let's go to do this problem. What it say this problem? It say figure 6.4 show a 3 kilogram ball tied to the end of a rope of 50 centimeter long, is moving in a circle, in a vertical circle. The center of the circle is h equal 505 meters, 5.1 meters above the floor. The ball is swinging at the minimum speed necessary to make over the loop. So he's having enough velocity to arrive to this point, not to stay here, to go and to make the turn. So have tension, have a little bit of tension here. Okay. So what it say, if the string released at the instant the ball is at the top of the loop, how far to the right of the center of the circuit does the ball hit the ground? So if the ball hit with if the ball arrive here with certain velocity v, that we need to figure out what is this velocity. After the rope break, if the string is released at the instant the ball after the string is released, so the ball will do a parabolic motion and will land at certain distance x, and this is the distance that they want me to find. Okay, the first thing is to understand what is this situation. What is the velocity that they are talking? They are talking about a force that at the top there is the mass m, there is the tension going downwards, and there is the mg. So at the top, the Newton's equation would say the sum of all the forces, T plus mg, equal mass by the acceleration. But the acceleration should be v squared divided by r, because it's the acceleration of a circular motion that is not uniform, but at this point, the acceleration going downwards, wow, yeah, should be this one. So, if I consider that the tension break, the equation will be mg equal mv squared divided by r. So the v squared necessary is g by r. Because the m cancels, so v squared is g by r. So the v is the square root of g by r. So the v is the square root of r by g. R by g, I know r, I know g, is 1/2 by 10 raised square root of 5. Okay. Now it's a problem of an object that is being launched with velocity v equal a square root of 5 meters per second, and is being launched with this velocity. How far it will go. So we use our equation of motion with constant acceleration that we have learned in chapter 2 and chapter 3. So the y is y0 plus v0 y by t plus 1/2 by t squared. What is y0? Y0 is the initial height, and the initial height is 5.5, right? Is 50 is the initial height is this h is 510 plus 50 centimeter of radius. This is the initial height, 560. So I did a mistake. Here is a 6. 560. 5.6 meters is the initial height, plus initially it doesn't have any initial velocity, minus 1/2. So this is the equation for the y. The equation for the x is x equal x0 plus v0x. If I choose my system of reference like this, the initial position in the x direction is 0. So the x0 is 0. So the equation will be like this. So I have two equations with two unknowns. So I will find what is the time t to land to the floor. So the equation will be y equal 5.6, here is a 6 minus 5t squared. If y equals 0, the equation will say 0 equals 5.6 minus 5t squared, and this will say that the time squared to achieve this point, the floor, will be 5.6 divided by 5. Okay. And what is the x? The x is moving with constant velocity, so the x is vx square root of 5 by t. At this precise time, the value of the x will be v, the velocity, by t, but t is a square root of 5.6 divided by 5. So I would say a square root of 5.6 divided by 5, or by a square root of 5. This is the t. So making the calculation, I should find the x. And the x should be, I don't know, one of these answers, right? You look which one of the answers should be. Okay. Next problem will say a 90-gram bed on a 60 centimeters long string is swinging a vertical circle about the point 200 meters. So this is 200 meters, yes. This distance is 200 meters. Okay, let's move to see if okay. About the flow, the tension of the string when the bed is at the very bottom of the circle. So when he's here, so he's coming from here, When he's at the bottom, the free diagram of the body will say that there is tension going up, there is the weight going down, and because it's a circular motion, there is acceleration going up in this direction. And now, what is bigger, the tension of the weight? Well, the tension should be bigger because the acceleration is in this direction. So if there is more force in this direction, will produce acceleration in this direction. So T minus mg should be mv squared divided by r. Okay, so from this equation, I can find v squared. Correct, v squared will be r, the radius, t minus mg divided by m. And now this is v squared, so v is a square root of everything, of this thing. And it gives you, at the bottom, it gives you everything. It gives you the tension, 2.2. It gives you the mass. It gives you the radius. It gives you everything. So find the velocity at the bottom. Okay, let's go. Next problem. Okay, this problem says a satellite having a orbital velocity v orbiting a planet of mass m. So this is the mass m, this is the satellite, and it's orbiting around the mass m in a circular motion. If the planet had half as much of the mass, the orbital speed of the satellite would be. Okay, if you decrease the mass to half, what velocity will need to have this object? At the same radius, I suppose. To what? To perform a circular motion. So the force acting is the gravitational force, and the gravitational force is minus gmm divided by r squared in the direction of r, and the direction little r, unitary vector, is here, of course. And force is mass by acceleration, and the acceleration is the centripetal acceleration because he is performing a circular motion. So in this case, what I have is that the mass cancels with the mass, and the acceleration is gm divided by r squared, but the acceleration is the v squared divided by r, that is the centripetal acceleration. So the v squared is this equation. If the radius is very big, the v squared is very small. Okay, in these circumstances, for the radius r0, the velocity v that we are talking, v0, for the radius r0, is this expression, gm0 divided by r0. So what happens if the mass going to half? If the mass going to half, v squared will be g. Now the mass m0 go to half, and the radius r maintain constant. So the new velocity will be 1/2. This half is 1/2 gm0 divided by the radius r, capital R. But this is 1/2 of mbc, 1/2 of v0 squared. So the relation should be that the velocity v is 1 divided by square root of 2 by v0. From this equation, I have found this equation. So if you have a, so what it means, this is like this. If you have a planet of mass m and an object of mass m orbiting in a circular motion of a radius r with a velocity v0, and the satellite is performing a perfect circular motion. Now, if you take the mass of the planet, and you reduce it to half, and you don't touch the radius r, the same radius, and you want to put the mass m here, and you want to make this object to do a circular motion, now you need to decrease the velocity in a factor 1 divided by square root of v0. Otherwise, the object will not do a circular motion. Okay, this is the problem. Okay, next one, it's a ferry wheel has radius 5 meters and makes a revolution in 8 seconds. If it makes a revolution in 8 seconds, means that one revolution is 2 pi radians. It makes 2 pi radians in 8 seconds. So the angular velocity is the angle divided by the time. The angle performed in one revolution is 2 pi. And the time performed in one revolution is 8 seconds. So 2 pi divided by 8 is pi divided by 4 radians divided by second is the angular velocity. It's a person weighs 670 newtons. So the weight is here, is 670 newtons. Is sitting on one bench attached at the ring of the wheel. Okay. What is the apparent weight, the normal force exerted on the bench of the person as she passed through the highest point? So when she passed through the highest point, it say the highest point. So let's go to do it. Oh, the highest point. So this is rho. So through the highest point, there is the normal force going downwards. So this is the wheel. He is at the highest point. This is mg. And there is normal force pulling downwards. So the equation that you will place for Newton's law will say that sum of all the forces equal the mass by the acceleration. What is the sum of all the forces? Is mg plus n. So I have chosen going downwards positive. And the acceleration, because it's a circular motion, the acceleration is going in the positive direction, going downwards. This is a acceleration A for a circular motion. So in the top, the acceleration will go downwards. Okay. So the normal force will be let me erase here. The normal force will be MA minus mg. mg is going downwards. The normal force is going downwards. At the top, this is the wheel. Oh, a ferry will have a radius 55 meters and makes a revolution. A ferry wheel, what it means a ferry wheel? Is the person here outside? I think that the person is outside. This is why I put the. I think that the diagram at the top is like this. The person is outside the ring, so the normal force is going downwards, and the weight is going down. It is upward, the normal force, and the weight is going downwards. So I was doing the correct things. So let me erase again. So the equation will say the sum of all the forces equal mass by the acceleration. So I will choose the acceleration at this point is in this direction. So I will choose the positive direction in the direction of the acceleration. So it will be the weight mg mg is the guy is minus n going up, minus n going up. So this is the wheel, and the person is outside, okay? Because if this is the wheel and the person is inside, the total force will go in this direction because the acceleration is going in this direction. But the total force will be produced by the weight going downwards and the normal going in this direction. So I'm supposing that the guy is here at the top, that he's outside the wheel, the force, the mg, is going downwards, and the normal force is going upwards. This is what I'm supposing. So, because the acceleration is going downwards, the acceleration is positive, so mg is positive. So plus mg minus m equal ma. So the normal force will be, let me erase again, I'm sorry. Let me erase again. The normal force will be mg minus ma. Mg is how much? Mg is 670 newtons. M by A is m. See, if mg is 670 newton, is because m is 670 divided by g, or 670 divided by 10, or 67. So mg is 670. M is 67. And the acceleration is v squared divided by r. V is 4 squared, and the radius is 5 meters. So it's A on the problem. I'm not. So the normal force will be 670 minus this. So you calculate how much is the normal force, and this is the apparent weight of the object. I think this is all. This is all. Oh no, there is one more problem. Let's go. 1,000, so you have two masses, one with 1,500 kilograms and the other one with 1,200 kilograms, A and V. The distance that separates the two masses are 1 meter. And here there is gravitational force. They are very, very tiny forces, very, very tiny. But the problem say, let me read it again. Yeah. You put mass A here, you put mass V here. A third point mass is placed between the mass at 20 centimeters of B. So there is 20 centimeters from A. Find the magnitude and the direction toward A or B of the acceleration of the third mass. So the mass MC will receive two forces. For one side, the mass MA of 1,005 kilograms will make a force on C pulling the object to the left. For the other side, the mass MV will make a force on little m of MC on this object to the right. I don't know which one is a bigger force. If this is the bigger force, the acceleration will go to the right. If the other one is bigger, if this one is bigger, the total force will produce a force in the negative direction and the acceleration will be to the left. The only way is to calculate what amount of force is to the right and to the left. So the force due to C, the force acting on C due to A is G MA MC divided by the distance squared. If everything is 1 meter and this is 0.20, so this is from A, this is 0.8. So I made a mistake. The distance square is 0.8 square. So this is the distance square from the mass A. I'm sorry, it's not my lucky day. MC, so 0.8 square. So the force, I can calculate the force acting on Z due to A is minus G. G is 6.61 by 10 to the minus 11. You see, it's more. This factor makes, this constant makes that for a small mass, the force will be at the end very small. 1,200 by 1,500 divided by 0.8 squared. So you calculate this force. Now you do the same thing. What is the force acting on C? On C due to B. On C due to B is G MV by S multiplied by MC by the distance square. The distance square is 0.2. And 0.2 square, so you make the calculation. The same calculation, G MV plus MC. MA plus MC, so I did it the wrong calculation. MA, let's go to see. MA is 1,500. So 1,500 MA, and MC is, how much is MC? MC, MA, MV, poema, hey, it doesn't say what. 1,200 must be 1 meter per. A third point must place between the two on the line. Find the. Oh, it doesn't say, but we don't need. We don't need. I realize we don't need MC. So this force, the force on V, the force acting on C due to V, is G and V and C divided by 0.2. So it will be G. Even we shouldn't calculate anything. Don't put the G here because you will find that if you don't put the G, you don't have to make any calculation at the end, I think. Let me do it. So this is the G, well, I put it, G by MV. MV, it's say 1,200 by MC. MC I don't know, but I don't need to know. Divided by 0.2 squared. So this is the magnitude of the force acting on C due to V, on C due to V. And this force is going to the right. Let's go to put it positive to the right. And this force on C, acting on C due to A, is going to the left. So let's go to put a negative sign here. So there are two forces. One is acting to the left, one is acting to the right. So the sum of all the forces equal mass by the acceleration. The mass of C by the acceleration of C. So the sum of all the forces is 1 to the left, G, MA, MC, the product of the mass divided by the distance squared. The distance square, the distance square is 1 minus 0.2. Sorry that I made a mistake here. And 1 minus 0.2, you know that is 0.8. Okay. So this is the force acting on C due to A. And this is the force acting on C due to V. This force, the first one, is negative. The second one is positive, is going to the right. And the sum is the total force. And the total force is the mass by the acceleration. What mass? The mass of the object of C. Everything is acting on C. The force on C. The force on C due to A. Okay, this is the mass. Oh, but now I know that the mass will cancel. Mass C will cancel. Mass C will be cancelled. Oh, I have AC. So AC is this one. All these things. So what I have to do now is to plug in numbers. The G is 6.6 by 10 a la minus 11. Now MA is 1,500. 1,500. Divide by 1 minus 0.2. I made a mistake. Divide by 0.8 square. And this is negative. And positive is the G by MV, 1,200, divided by 0.2 squared, the distance from the mass MC to the V. The distance was 0.2, and it's the distance squared that we use for the force. So, what is the total force? What is the total acceleration? Well, I suppose it's a very tiny acceleration. Let's go to calculate. So it will be, the acceleration will be, A will be 6.6 by 10 a la minus 11. That is a common factor of everything. 1,200 divided by 0.2 squared is 2 by 10 a la minus 1 squared. This is 4 by 10 a la minus 2. 10 to the raised to the minus 2. So 1,200 minus 1,500 divided by 0.8 is 8 divided by 10 square. This is 64 divided by 100. So the 100 will go up. So the acceleration will be 60.6 by 10 to the minus 11, 1,200 divided by 4 by 10 raised to the 2, okay, minus 1,500, 64 by 10 squared. Now we see what is bigger, this one or this one? I don't know, you calculate. If it's the result that this one is bigger than this one, the acceleration is positive and is going to the right. If not, it's going to the left. Okay, you finalize the problem. Good luck. Oh, sorry.